Or and like recording in cloud as well, might as well. You can do it. Can't you do it?
No, I'm going to sit down there and let you sit. But yeah, I'm pretty sure it's unmuted as well, so we'll see if the mic comes through. May or may not. Hopefully it will.
Just make sure you mute other people and make sure you mute everyone else.
Yeah.
They can't share screen.
Yeah, she'll do that.
Oh, she's on the account.
Yeah, we're using her Zoom. Awesome. Hi, everyone. Welcome to the Google Developer Student Club's Intro to Hacking and Secure Coding. And today we have Helen joining us from Aura Information Security. She's, yeah.
I'm too short and that was blocking me.
And yeah, I'll let Helen introduce herself.
Sure, thanks, Matt. Hi, everyone. My name is Helen, and I currently work at this company called Aura Information Security. So I studied at Auckland Uni, I don't even know how long ago now. I graduated in 2017, and I did degree of comp sci conjoined with arts, and then I did 1 year of honors. Anyway, that took a while. And then so after I graduated, I went to work as a software engineer for a little while. I was working over at Microsoft, and then I was there for 2 years, and then now I'm back in New Zealand again and started working in security. So kind of when I was working as a software engineer, the security side of things just kind of really interested me, and that's kind of how I looked for a security job once I'm back in New Zealand. And now I've been working as a pen tester for about a year. And what we do every day is test security for other people's websites and try to hack into it and tell our customers what they can improve in their applications. And Matt here actually was an intern with us for 2 years. And yeah, so we'll be talking through a little bit about hacking and how to code securely. And Matt, do you want to quickly introduce yourself as well?
Hi, everyone. I guess like half of you probably know me or see me around. I'm a university student here, part 3 software this year, and yeah, have had the pleasure of working with Aura the last 2 summers.
Cool. All right, so we'll first start off with kind of just like talking a little bit about brainstorming a little bit of what hacking is and what is kind of your idea of hackers and what it kind of looks like. So does anyone want to just like shout out some ideas? What do hackers actually want? Like, why do they hack into things?
They want your bank account details.
Yep, bank account details.
I'll see the sense of this hackers can be both ethical and unethical.
Yep.
They want to deface things.
Yeah, defacement. What was that, sorry? Source code. Yeah, definitely. You can get really sensitive information in source code. That over there? Yeah, build botnet. And then they can do denial of service attacks with like billions of machines at the same time. Yeah.
They could also like put it back in like a backdoor or something.
Yeah. Yep. So when they hack into a network, put a backdoor there, and then they can always come back to it at another time. So they always have access to this network, hopefully without people realizing as well. And yeah, all of those kind of with the goal of obtaining some kind of information they're not really supposed to have, right? And so we're going to talk a little bit about, so for the rest of this talk, we'll cover 2 main issues. I say main because they're kind of the 2 of the really common issues that we see still in security, but there's also plenty of them out there. So one of them is called cross-site scripting. We'll go a bit of detail into that later on. And then the next one is called SQL injection. And you may or may not have heard a little bit about them already, but yeah, we'll go into them later on. And finally, we'll also go over a little bit of tools and resources for you to learn more about if you're really interested in this field in your own time.
Last of all, there is the pizza. yeah, so
most importantly.
we'll be at the
Yes.
front, happy to answer questions about internships, and Helen can answer questions about just security stuff and all over Pete's, of course.
Cool. Great. So we kind of talked about this already, and then there's also kind of like this idea of, yes, they can, their goal is to get information that they're not supposed to, right? But how are some of the ways that they can get access to that? Is there anything you can think of that maybe you've seen, or maybe you would want to try if you're trying to hack your friend or something? Yeah, so hand in the back. Yep, passwords. Yeah, that's a really big one. Often you would get password from sites that's already been breached. So if you had an account with a website and the website got hacked, then your password could be out there, and then a hacker could try to get that and try to log into your other services, which is why we recommend password managers for everyone. Use different password for everything. Your hands over here. Yep.
Use something like Wireshark and check your packet serving.
Yeah, that's right. So even if you're on like the Union network, if you open up Wireshark, it's a package capturing tool. You can kind of see what everyone else is sending across the network, like what websites they're looking at. But usually they're encrypted because we're using, most websites these days use TLS, which is when you see the little lock next to in your browser, next to the URL. But which is why, yeah, if we send anything in clear over HTTP at any point, then someone could see your password through something like Wireshark. Was there another hand? Yeah.
I would just say that, like, for most security, on most practical application security, humans is the weakest point of defense. So
Yeah.
they're just like sending a lot of spam or spoof emails, trying to explore the psychology and so on.
Yeah.
So they can.
Yeah, that's right. Yeah. So phishing emails is a really big thing, especially for corporations. You might get ones that's like, click this link, you have a package waiting to be received, and put in your credit card detail. And so they're trying to get your credit card detail that way. Or companies, sometimes they're really targeting, if they're trying to hack a company, they'll maybe try to send the IT admin an email, and they'll try to be like, hey, log in with your company credentials and see something here. And so once they do that on an attacker controlled domain, then they'll be able to see the password, log in as the IT admin, and then basically see everything within the company as well. So this is one of the reasons why, phishing emails are actually a lot more serious than just like a Nigerian prince kind of scam, especially for companies with a lot of things they want to protect. Yeah, so moving on to the next part. So we've talked a little bit about different kind of ways that attackers could potentially gain access to things that they're not supposed to. And which is why when we are, as developers, when we're building a web application, we need to really think through what are some of the ways that attackers could try to exploit the application that we're building. And so I mentioned briefly earlier that there's two issues that we're going to cover today. And so the first one is called cross-site scripting. And this is one of the ways that an attacker could potentially exploit a vulnerable website that you built to attack the users of that website, right? And then potentially get information about people who are using your site, and then go from there. So first of all, just want to kind of cover what is actually like a web page or a web application, right? So in a very basic on a very basic level, they're basically made up of three different kind of files, right? Like grossly overgeneralizing, don't need to correct me. But yeah, so basically they have HTML files, which are kind of declarative. It's a declarative language which you use to just describe what sections a page is going to have. Then we have the JavaScript, which is kind of like the brains of the application that goes and do things like click this button. JavaScript will have some kind of logic that will trigger an event and do something in the back. And then CSS files, which is a static file which you can use to describe what the page is going to look like. So title, I want the font color to be red, background color to be blue, that kind of thing. Don't do that, that actually sounds really bad. Blue and red. So yeah, so kind of like what I mentioned briefly, JavaScript is actually what you really care about in a structure like this, because the other two is just kind of used to describe things, whereas JavaScript is really what you can do a lot of things with, right? So you can either have it as a separate file, .js file, or sometimes you can actually directly embed it into HTML files as well. So HTML has tags that describe different things, and JavaScript is one of the tags that you could add, and you can trigger different tags to do different things in JavaScript when you do different things in there. So there's so many things you can do with JavaScript. So this is kind of like a really basic HTML file, assuming you guys have all seen this before. If not, you can go function F12 on your computer and see what the source code of the site looks like. And it will generally have the same structure as this. So this is what I meant by one of the tags that you can do. So in here, everything inside the script tag is interpreted as JavaScript, right? So alert is one of the JavaScript functions that essentially creates a pop-up. And so this one will look like, says this is a heading, and then when you open the page, it will have a pop-up that pops up and says hi. So going back to this idea of cross-site scripting, right? And we talked a little bit about how JavaScript is really important. Cross-site scripting is basically an issue where someone can inject their own JavaScript code into the web application. So this could have very serious ramifications, as you can imagine. If someone can run JavaScript in your code that you didn't write, they could do all sorts of different things. And this usually happens as a result of some kind of functionality that takes a user input. So anything that you can think of that has an input box, like a search box, username, password, login box, or yeah, like anything really that where a user can kind of make a request to the web server and to ask for a certain thing, and this user input is then added to the page without really, and the website is not really checking like if the user input is actually legit before actually adding it back to the page. So what could then happen is that an attacker could create a URL of the site, which basically generally kind of looks like adding an input in one of the request parameters, and the request parameters will have some kind of JavaScript code in there, and it would then be the JavaScript code would then execute when a user clicks on this link. And so someone that uses the application sometimes then when they click on this link, they're not going to just have the code that you wrote, but also the code that the bad person wrote. And this could look all sorts of different things. Right. And this is just kind of a diagram of what I just talked about, where you start with an attacker, they create a link that has JavaScript injected into it. They send the link to the victim, maybe through a phishing email, right? Or like pretend to be someone else and send a link to them. And then they click on this, request the legitimate website that you're hosting and you're running. It loads it, but also the script is also run that was written by the attacker. And then the script could potentially look like sending an HTTP request to one of the domains that you control. So then you would be able to see a request coming from the user who clicked on this link, and it would then go and send through their personal information, like their cookies or their account information or whatever really that JavaScript has access to in the application itself. So we're going to do a quick demo, and I'm going to hand over to Matt for this part. Cool.
So I've just created a pretty simple demo script. It uses PHP. So, and I guess an overview of that is it's a dynamic server-side scripting language. So you can, so it can be used to take input from the request and then create a dynamic web page out of that. So I assume most people have seen that. JavaScript we've covered, and a link to the demo if any of you also want to have a look at that. I wonder if I can click on it like this. So yeah, not secure.
Not secure.
I didn't bother to set up TLS certificates there. So if we say, hi, my name is Bob, then the PHP will take that user input and generate a web page based on it. So it will say, hi, Bob, go.dscuoa.nz. So you can, I don't know if you can see that. Oh, you can see the name is Bob up there. So in this PHP file, there is no input sanitization of any sort, and it just takes the input and then echoes it straight back to the page. So we can inject our own HTML tags by just typing them in. So this will make it bold, for example.
I think it got deleted.
Bad.
This became.
Oh, name is bold. Okay, that's a bit better. So we can see that up in the URL bar, we have our evil script tags, as well as our name or our evil HTML tags, which can be used. So we can, instead of just making it bold, for example, we can obviously run scripts by putting in other tags. We could insert images. We can change the styles of this web page if we wanted to. You can do anything, write any HTML elements like that. Most of the time, though, the attacker will be interested in stealing a user's cookies, which are used for session identification. So if you've authenticated against the website in the past, then your cookies will hold that authentication status. And if an attacker got those, they would be able to pretend to be you. So an example of this would be if we type in this script. Oh, well, I suppose. Oh, this is really weird typing on a different screen. Oh, we have no cookies. Whoops. Oh, well.
But normally, if that works, then you would see the user's cookie in clear text, right? So there's a way where you can set your cookie and make sure it's not accessible from JavaScript to prevent something like this as well. But that's just a side note.
I'm just going to go grab a cookie so we can demo it. Okay, we've logged into this other notes app, which will be used later. And now we'll go back to our bad thing and try and view our cookies. So that's just the same ones before. And now when we view our cookies, we can see that my PHP session ID for when I logged into that other site is this random string. And then if an attacker was able to get that, then they could pretend to be me on the other site. Or on the other site on the same domain. That's that.
Does that make sense for everyone? Do you want us to explain anything?
So over here we have an example of the vulnerable code, which is it takes the name parameter that was in the URL and just echoes it straight back to the screen. And we saw that it didn't do any input validation and just printed all the characters as they were input. So that is our bad.php file. Next one. This one. This is an example of what the HTML will actually look like after we put in all our different things. So with the input being script hi, it just gets splattered onto the page and it says hi there in the script. That's that one. So there's two common fixes that I say in quotes because they're not fixes, but I've seen them around like during my internship and outside of that as well. And the first is just delete any script tags, right? Surely that'll be secure. If you can't type in a script, then they can't run their JavaScript tags. So that's also, we have an example thing. You're welcome to have a try typing that in if you want. So this is how it will be implemented. We just take the name input, replace any script stuff or delete it, delete the word script wherever you find it, and then print it to the screen. The problem with this is that you have your script tags and then it finds the word script, deletes it, and in doing so creates a new script tag, which obviously ends up printing this to the screen and bypasses that fix. One way that you could improve this is just keep on looping, and then whenever you find a script tag, try again. But that doesn't solve all vulnerabilities and shouldn't be your go-to solution.
And also just a side note that there's so many HTML tags that can run JavaScript. Like, script is just the most obvious one, but you can do it in image tags, you can do it in links, you can do it in like.
You can do it in anything because you can just go when the user mouses over something, then do the thing, and you can so you can do it in basically any tags. So removing script tags isn't your solution. The next fix that I've seen is just remove all the tags, right? So we're going to encode the angle brackets or the less than and greater than signs. So the user won't be able to input tags. But of course, that's how you could implement it, is you find any less than or greater than signs and replace them with the safe, like display only, I guess, HTML entities. But this will fix this one, I think, because you can't add any, this will fix any cross-site scripting in this tag, because you can't add any script tags. So you're just printing essentially text to the screen. But if you were to have another, I guess, if you were already inside a script tag, then there would be a new vulnerability introduced. Is that one way to put it, I guess?
Yeah, so it depends on where the input injection is happening, right? So in the example that we have, we're injecting into HTML. So the code around it is all HTML. But you could also have cases where the injection point, the parameter is being used in a JavaScript already. So in that case, you could just directly run JavaScript without using the square brackets around it. So so depending on where the input is actually used, you may not necessarily need to have the square brackets.
And this is just an example of how we would, without using the less than or greater than signs, create cross-site or exploit the cross-site scripting vulnerability in this, is we would have our input being this on mouse over, do the things, or steal your cookies. And you can see that it doesn't use any angle brackets or greater than less than signs, and it just creates a new attribute that says, when you mouse over this input field, I'm going to steal your cookies. Yeah. So the real fix is to encode any user input when you're printing it, when you're using it. So if you take user input and then want to print it into an HTML file, you need to encode all the HTML special characters. If you want to like inject it into JavaScript, you've got to sanitize it against all JavaScript special characters. So in PHP, the function to convert special characters to HTML entities is called HTML special chars. And there's equivalent functions in pretty much every language. I know that lots of languages you use these days, like React or lots of frameworks will escape characters by default, and then you'll need to add this vulnerability, you'd need to call dangerously set things, which is really good because by default it's safe. Yeah. So this is an example. This is showing how we would fix the code. We use HTML special characters. This says that we're going to encode quotes as well. It's just one of the settings in HTML special characters. So you do need to read the docs. And then what sort of character encoding we'll be using.
Cool.
Back to you.
Yeah, so that was the demo. Hope it makes a little bit more sense. And this is just kind of like a funny story kind of thing that wanted to show you guys that this is not just like a theoretical in the textbook kind of vulnerability, right? So MySpace was kind of like the Facebook before Facebook, or before like many versions of social networking websites. Does anyone remember it, or has anyone used it? Okay, cool. Just making sure. Yeah, me neither. And so what happened was in 2005, wow, that's like 16 years ago, I think so. There's this guy called Sammy, and he was just on MySpace, and he found that, hey, there's actually a place where I can inject JavaScript code into it. And so he thought he could have some fun and add something to his profile. And what he did was he wrote a JavaScript code that basically, whenever someone visits his page, the code executes in the other user, and he used JavaScript to add this line to the other person's profile that just said, but most of all, Sammy's my hero. But also it added the same payload, the same code to the other person's browser, the other person's profile. And so someone else visits their profile, the same thing is executed, and it goes on to spread to basically everyone, right? So as you can imagine, yeah, this could get out of hand very quickly. And this is why it's called a worm, which is just a way to say that it's something that replicates itself and it spreads that way, right? And so what ended up happening was that basically in just less than 20 hours, over 1 million accounts was infected. So everyone had this line on their profile when you went around to it. And MySpace was taken offline for a few hours. And then a couple of months later, the police caught up with him and was like, hey, why did you try to hack MySpace? And then he was like, oh, I'm sorry, I'll try to make up for it. And so he didn't end up going to jail, but yeah, so don't, and also a note of warning, like don't try this randomly on websites out there, right? Make sure that you have permission with the website to test. Otherwise, yeah, you could get in trouble if you actually do get access to information you're not supposed to. Yeah, so just a kind of a fun story. And we're going to move on now to SQL injection. So this is another very serious issue, and arguably a little bit more serious than cross-site scripting, right? Because now we're dealing with databases. So just in case anyone doesn't know what it is, SQL just stands for Structured Query Language, and it's a kind of the most commonly used database language out there, right? There's a lot of new ones coming along now, like NoSQL and stuff like that, but this was kind of the most traditional one and what is still being used by a lot of organizations out there today. And essentially, when you're wanting to deal with database, database is divided into tables, and then in each table you have columns and different rows, and so every information is inserted into tables like that. So when you want to read something from a database, you essentially have to say something like, hey, I want to select the user ID column from the table called users, and I'm going to set a parameter where I want everything where the age column is larger than 18. So you can do things like this, and it will return you a number of rows in the database with the information in there, right? And so, as you can maybe kind of imagine, if SQL is something that we can use to communicate with databases, then if someone can inject code into our database, that would be really serious, right? Because then you're not just dealing with session cookies, which is bad enough already, but you're directly dealing with something that your organization is storing, and it's very important. So similar to cross-site scripting, they're both called injection issues because they essentially inject something into a input box or something like that on the web page, and the user input is not really sanitized and doesn't really check for what you're putting in there, and it just takes it as it is, and usually takes it directly and adds it to the code that it's running. And so in this case, an attacker could execute unauthorized SQL code in your application. So this is a PHP excerpt again, and this essentially it's saying, I'm going to take, so the post, the underscore post is just saying a parameter that you're sending in a post request, right? So you have user ID. I'm going to take what the user put in the user ID input, put it in that variable called user, take the password input that the user put in the post request, put in the password variable, and this is, and then you're writing a SQL code here to say, I'm going to select ID from users where ID equals to user and password equals to password, right? Which looks fine if you're just looking at it, like it makes sense. Like, I want to read these things that the user is telling me to, and this is what I'm doing when I'm logging in. And I want to check if the user ID and the password matches up. And so if this does return something, then I know that yes, the user and the password does match up. So this is kind of what a developer that just kind of comes into contact with PHP and SQL might write, because it's really straightforward and it makes a lot of sense. And we're going to see how there's going to be a lot of issues with that. And I'm going to hand back to Matt again for the demo. So take it away.
Yeah, so once again, we have this demo here, and it's a vulnerable notes app. So we have some functionality, we can sign in or register. And since we don't have an account, we will make a new one. I'm just going to make my password A because it's super secure. Then in this, we can add notes, and you can see up over here, so I'm user 4, and over here, we're grabbing all the notes for the user, which is user 4. I can't grab them for user 5 because I'm not logged in as user 5 and also doesn't exist, but nor can I do it for user 3. We can delete notes and add multiple, but if I go back to my slides, I think, Hero, can you stop? Thanks. Back on the slides. So this is actual code, I think, that I do. And it says select all the columns from the notes table where the user ID is whatever I put in that query that you saw up there. So I was user 4, so it would say select everything from notes where the user is 4. But using SQL injection, you can break out of this bit and then add your own SQL code afterwards. So this example shows that if I pretended that my user was 2 or A equals A, then it would generate this SQL query, which would select where the user is 2 or this expression is true. And obviously A is always going to equal A. So this bit evaluates the true. So it will select everything from notes regardless of the user. Does that make sense? So if I jump back to, how do I do that? Escape, magic. Oh, I hope I didn't lose my place. But so I will do that up here. So we have user equals 4, and then our single quote to escape out of that quoted area that there was, and then or, well, you can use any letter or number, I suppose, or A equals A, and that will generate the SQL query that will show me all the notes. And you can see that, okay, my website is buggy as well, but it has other users' notes and displays them all just as if they were yours. That's that one. Oh no, please don't. Oh well. I'll present my presenter.
Close that. Just
Sure, I can just bring it
this
here.
one because it's back here. Yeah.
Magic. Okay, so fixing the code. SQL has this amazing, or SQL has this thing called prepared statements where you craft a SQL query that's not quite complete. So you prepare it by saying you're going to want to look at users, you're going to want to select the ID column, and it'll just have these parameters which haven't been specified yet. So you prepare that and you send it to the server, and then you get a statement back, which you can set these variables on and then specify what type of parameter or what type of value it is, and then execute it. I'm also missing a semicolon there, ignore that. So this will avoid the SQL injection vulnerability, because instead of directly putting the user input into the SQL query, it's binding it safely, and this function will do all the escaping for you. Also, this is better performance if you're doing lots of queries for ID and password, because it only needs to prepare it once. That's just a side note. So you should do it like this because it's better performance and safer.
And that was just like a PHP specific way of doing prepared statements. There's languages, well, in pretty much every language that deals with PHP, you can find an equivalent way of doing this as well, just depending on the syntax. Yeah. And so finally, another fun story thing. So if we,
the screen is like the other way around. So if you push the mouse off that way, then it goes onto the screen.
There we go. Okay. So yeah, we're still in 2005, 2006 kind of era, because somehow that was a time when people didn't really care about security, right? And you get all these kind of big security issues happening. And another really big one that happened around that time was with a company called Rockyou. And has anyone heard of this company before? Yeah, that's right, from Wordless. And this is how they got it, right? So a company that was dealing with MySpace once again. Somehow everything related to MySpace seems to be a bit insecure. And what happened was in around that time, 2009, this company had a data breach, and over 32 million user accounts, which is a really large number, their user account and passwords were exposed. And this essentially happened because of a SQL injection issue that was on their site. And so from that, an attacker could basically download the entire database, right? And then in the database, you could see all the username and password. And so just some newspaper articles at that time, but what was really bad about it was that the data was stored in clear text in the database as well. So in the user table, they had all the usernames in clear and all the password also in clear. By being in clear means it is literally what it is, right? It literally is your password saved directly in the database. And this is not something that you would see very commonly nowadays, because we hash everything. We hash the password to turn it into a really long string of a set length, which is a one-way operation. So there's no way of reversing it. So you can't get back what was originally there unless you try and just to guess what the original thing was, use the same hash algorithm and compare the hashes, right? So this was kind of like a reminder to people at that time that storing passwords in clear is really, really bad, because if you do get hacked, if you do have a data breach of your entire database like RockU had, then all the username and passwords are out there. And so what happened was, basically like you mentioned, we get our favorite password brute forcing file, which everyone kind of uses for CTFs and different things. And you would basically, so when you're brute forcing a login, if you say if you have a valid username and you want to try a bunch of different passwords on it, you would run a word list like this, right? And you would try to run it and log in as fast as you can and see if one of them logs in, and then you would know that this was the right password for the username. And as you can see, this is just doing a word count that's like just over like 1.5 million, which is only a fraction of what is that 14 million? Okay, yes, 14 million. Okay, still a fraction of like all the credentials that were breached, probably because these ones are unique ones, so they don't repeat themselves. And yeah, so basically this was kind of the first time as well that the world kind of saw what password people were setting, because it was if I recall, it was probably one of the first ones that had such a large number of passwords that were exposed.
Also, what's interesting about this is out of the 32 million user accounts, there were 14 million different passwords. So that means half of them use someone else's password, which is pretty bad.
Yes, probably likely because you have passwords like password and things like that. You probably have like thousands of people that use those kind of things. So this is what happens when you don't have a password policy on your site as well, right? So if someone can just set whatever password they want, and this was before the times of our password managers, you would just try to use something that you can remember so you can log in quickly and not lock yourself out. But yeah, this is just to show SQL injection is a very serious issue. And if you don't deal with it properly, there's going to be basically newsworthy things in the news about the company.
And there's all these new data laws, like in New Zealand now, if you have a data breach, you have to report it, like if it's serious, which is up to your interpretation of serious. But like things get legal very quickly when people steal other people's data. You don't want that happening with your code. Yeah,
that's right. Yeah, another cautionary tale was what happened with Yahoo a few years later than what we're dealing with here, I think, or maybe it's still around the 2000 era. They had a data breach, didn't report it for like quite a long time. They were just trying to keep it down, like keep it really on the down low. Didn't want people to know about it because they were going through acquisitions, they were trying to sell the company. They didn't want bad press going on, right? And then eventually when they found out, everyone just kind of flipped out and was like, what, Yahoo, how could you do this? Another reason why the privacy law Matt was just talking about came into effect in New Zealand, specifically last December. And so basically people can't be a Yahoo anymore and try to hide things if you have a data breach. Yeah, so that's the two vulnerabilities that we looked at. And here's just a little bit more like extra stuff that could help you if you're really interested in this area and you want to learn more about web security and or how to get into the security field. So Burp Suite is an application that is very commonly used, something I use every day for work now as well. Basically, everything is done through Burp and other things, but essentially what it is, it's a web proxy. And what a proxy is it sits between the browser, like Google Chrome or whatever you're using, redirects all the traffic to Burp. And then in Burp, you can then see all the requests that you're making to the server, which is the website. And during that phase in the middle, in Burp, you can kind of just modify the raw request that it's making, right? Like when you click on a button, you might not see it, but the web page is making like so many different requests to the web browser, to the web server, sorry. And so Burp just kind of slows it down, lets you see everything that's happening, every request that the web application is making. And then you can modify it in the middle and then sends it on back on its way to the web server, right? So that's essentially what it does. It's very simple, but it's a very powerful tool because as you can maybe kind of imagine, if we had the demo site we had earlier, we could intercept the request, look at what's happening, and just try to like automate what you want to put in the input field, right? And just like throw different things at it and see what crashes it, what happens. And then you can then go and dig into it and see, okay, maybe there's a cross-site scripting here. Maybe there's a SQL injection here. And that's how you would find a lot of the issues out there. And this is just a screenshot of the tool. Very brief overview, just kind of see everything that's been intercepted there. And yeah, this is the app that we were running. So you can see the request that it's making and the response that comes back from the server as well. So all of this is there, but the browser is more geared towards user experience, right? It doesn't like you can go into DevTools and look at the networking traffic there as well. But Burp really lets you modify things and just kind of look at everything that's going on and identify all the issues there. And this is just another tool. There's so many different scripts out there that can automate a lot of the issues, right? So SQL Map is just one of them that's related to, in particular, SQL injection. So you can just run it. It's a standalone script, and you tell it what website you want it to attack. And essentially, it's just going to go and like throw hundreds of requests at it. And if it does find a SQL injection, it would then go and automate all the requests to say, okay, we have a SQL injection here. I'm going to find out what are all the database names in this database. And then for each database, what are the table names? What are the column names? And once you have that, it's just going through and dumping everything from the tables. And you just run this like one-liner, and then it will return you the entire database, right? So this is kind of what the output kind of looks like. Tells you, starts at the top. And then it's like, oh, yes, we found the backend database is running SQLite using PHP. And then it's like, oh, yes, I think it's vulnerable. And now we're going to start dumping everything. So then you see how the password is dumped by this tool, just completely automated, right? Yes? Yeah, so it does all the requests itself. It's trying all the different types of database. And then once something starts working, it will tell you. All you have to do is to tell it what parameter to try. in the URL that it's doing. So if it's a post request, you give it an input file, go to burp, copy the request that it's making when it's logging in. Yeah.
So in this example, I don't know how much you can see, but I say Python run SQL map on this URL. The batch just means say yes to all like prompts because I wanted to be like fully automated, and then dump everything. That's all I did. I hit enter, came back a couple of hours, and it had said, hey, look, I found these things, and this is your database contents. It was a very simple injection and a simple database that didn't take too long, but that's what it can do.
Yeah.
And it works well.
Yeah, so like the batch, the prompts is just like these stuff. Occasionally it'll pause and ask you, hey, do you want to follow redirects? Do you want to do this or that? And you can just ignore it and let it continue. But yeah, once again, don't run this on like Facebook or
use it on your uni projects.
Anything.
Yes, that's all I can think of.
Yeah, things you built yourself, things that you own, or your friends built, maybe if they won't get mad at you. Basically things where you know that like a big company is not going to be after you if you did manage to dump their passwords somehow. Yeah. And a little bit more for the resource. So we have OWASP is kind of like stands for Open Web Application Security Protocol. I can't remember. Project. Yeah, that's right. And it kind of has a lot of information about web security on there. Every couple of years, it releases the most common web application issues out there. Releases the OWASP top 10, as they call it. Lots of resources on there on different issues and how to prevent them. And Web Security Academy is built by the same guys that built Burp that I showed you guys earlier. Also has a bunch of labs and theories on just giving you a place to try to use different security tools. So yeah, you can like run the tools on stuff on there, like they're not going to get mad at you. And there's also like heaps of labs out there. Pentester Lab in particular is really good for web application testing. Yeah, they kind of have a particular focus on web apps, and it starts really shallow. Like it's really beginner friendly, but it also gets really, really deep. Things that like even professionals probably don't really know. Super cutting edge stuff, all about web security. And then the other three is kind of just for fun, and it goes a little bit beyond just web application security, right? So you have like CTFs, capture the flag things where they would set you challenges, and then you would try to break into something and try to obtain certain objectives. So it's actually kind of fun. Yeah, pretty fun way of learning about security. You can check those out as well. And yeah, there's just so many resources out there for basically whatever you want to learn. So yeah, feel free to take a look at any of those.
Over the Wire is really good because it's completely free. They have web app things as well as like a couple of Linux machines, and I think they've got about 5 different categories, of which I've looked at those 2. Pentester Lab is, they have some free things, but you have to pay like, I think it's $35 for 3 months or something like that as a student. But those are like really good resources, and the free stuff's good as well. I haven't tried Hack Me, and Hack the Boxes, I guess, well known-ish as being a CTF thing. It's got boxes of various different difficulties on different sort of machines.
Yeah, right. So yeah, those kind of go into a little bit more about Linux security, and they might give you an IP address, and your goal is to become admin on that box, on that machine located at that IP address. And all of them have a free option and a subscription option as well. So yeah, like really easy to just get started trying them out if you don't want to pay money for it yet. Even though the subscriptions are generally quite affordable as well, in my opinion. But yeah. I think that's everything we have. Are there any questions about anything we covered, or anything else
Career-wise, so from your experience, would you recommend for people on university courses to take in order to get into the field of cybersecurity, as well as any certifications you did?
Yep. So I actually, like when I was at uni, I didn't really do any security stuff. Like I didn't really know about it, and wasn't particularly interested in it either. But looking back now, I would say in stage 2 papers, you definitely want to take the networking ones. So 210 and 215 ComSci, because those cover, I know they're optional in stage 2, which I don't think they should be, but yeah, if anything, I feel like networking is really essential to understand how everything communicates with each other on the internet, right? Which is kind of the backbone of it. And in stage 3 papers, I'm a bit hazy on that. But I think there is like a operation systems paper, which I regret not taking, which like I dropped it after I took it because I was like, this is really boring, but now I kind of wish I took it because it's quite helpful to know. And there's also a security paper, I think, in stage 3, yeah, but I didn't take it, so I don't know how it is, but I think they cover like yeah. Yeah, does that answer your question?
What about any did you have to do any certifications to actually get the first job?
Not really. So when I made the transition from software engineering over to security, I was basically, so what happened was at the company I was working at, they're really into security training for developers. So
This is Microsoft, right?
yeah.
So yeah.
So they had a lot of events by the security guys show us these kind of things, and I just became super interested in security. Started doing like stuff on this by myself. Like I was working on like Over the Wire, Try Hack Me, and like stuff like that, just to learn about it myself. And basically, I knew a lot of things about security just from what I learned, and that essentially got me the job. And now that I'm on the other side and dealing with hiring and helping to like hire interns and things like that, I know one of the things we look for more than really like certifications is kind of how interested they are in security, and are they trying to learn things in their own time, because it's not really something that is really taught, and it's something that you really have to put in some effort into learning if it's really what you're interested in. Yeah.
So one of the things is that like anyone who comes out of university, like it doesn't really matter what courses you've taken, you won't know that much about cybersecurity. So it really is a pretty much a level playing field coming out of uni, and the people who want the job the most will be the one who will get it and do the best at it because you want it. And I mean, I got an internship pretty easily, I guess. Well, but that's because I was very focused on cybersecurity, and it was something I did in my own time, kind of just because I liked making things, and then making things right is good, and I wanted to know how I could break them in. And Aura, well, Aura's always hiring. So it's not like you need lots of qualifications in order to get your first foot in the door, because there's so many opportunities there. Yeah.
Yeah. And there was a hand at the back. It's fine now? Okay,
Yeah.
Sweet.
So I think pizza's still on the way. So if you have any other questions, that's good.
If you refresh, I think there's a feedback form as well.
Refresh the presentation. How does
Yeah.
Feedback.
Yeah.
Oh. Wait, what? Oh, did I just miss it?
Yeah, it's on the slide you start.
Oh, wow.
Oh, right. You just wanted me to show like this feedback
The
thing.
QR code.
Yeah.
Okay, I get it. Yes, scan the QR code. I don't know where it goes. Hopefully it's something not dodgy. Yeah, we would love feedback from you because this is like one of our earlier events. And I think it's actually our first in-person talk. So it would be great to know how we did and what you'll be interested in looking at next time or in future events. So that whether that's a workshop, another talk, it's really good to see everyone scanning it. That's great. I wasn't expecting that.
Unfortunately,
Cool.
Pizza's Eastman will run at 16, so they're a little bit early for you.
Yeah.
That's all right.
I'll put up, after you have all scanned this QR code, I will go back to the slides with either the cross-site scripting, or I guess the cross-site scripting one's probably the most accessible one. And then you're welcome to have a go hacking this like crappy site that I set up. Yeah, if you can get it to show an alert, we might have prizes. Yeah.
More pizza. Yeah.
Yeah, more pizza. Yeah, you get twice the pizza. Yeah, awesome. What now?
Wait for pizza.
Has anyone still scanning this? I don't think so.
Just my question, what's your day-to-day like job?
Yeah. So we basically, it's basically project based because we are working for a consultancy. Essentially, you can either work for a big company and do pen testing internally for everything that they're making that goes out of the door, or you work for a consultancy like what we do. And essentially, we are just a bunch of people that tell the customers we know security really well, and then they'll come to us and be like, hey, I heard you know security, can you test this site that we made, or test our internal network, or do whatever to make our company more secure. And so each week, or depending on how long the project is, you get put on different jobs working for different companies, and just kind of get a link, and then you're supposed to hack it and then write a report on it at the end of it, talking about different issues you find and help the customer to fix it, different ways that you suggest that they should implement fixes so that they can make things more secure. So day to day, I guess, just kind of yeah, like in the project lifecycle, I guess first couple of days, you just be looking at the site, running some scans on it. There's like automated scanners that we use, but they don't really cover a lot. So a lot of it, we have to go and click through things manually, test different things, and if you see this functionality, and try to see what issues there could be. And then towards the end of the project, you kind of need to start writing the report. And then basically, yeah, it's a lot more writing than what CompSci has prepared me for, I guess, because never got to write essays in CompSci, but you just kind of pick it up and you write the report and kind of just explain to them what the issue is, and then deliver the report to the customer. So yeah, it's also a lot more customer focused than being a developer, I felt like, because when you're a developer, you're mostly talking to your own team or like a PM that tells you what features they want to see. You really don't get to talk to the customers directly, whereas in a consulting role, you need to kind of have good communication skills as well, and always sending emails to customers and tell them if things are going to be late, or call them up if you find a really serious issue, like if you find a SQL injection and it's out there on the internet, they'll probably want to fix it straight away. So things like that.
Life as a consultant is pretty chill because you're trying to find vulnerabilities, and if you don't find any, it's a good thing. So you'll be assigned days to do the work, and obviously you do want to find something, because otherwise they've wasted their money essentially. But you're not going to find awesome vulnerabilities in every site, and no one expects you to. So yeah, it's.
Do you do like physical assessment as well, so you actually come on site, test the network?
Yeah. So
You get the devs there from the developers as well.
what was that? Sorry.
You get the devs there from the developers as well.
Most of the time, developers don't really know who we are, but yes, from the IT people. Yeah, we do that for internal networks, just go in, plug in our laptop, pretend we're an employee, and then you can do things like spinning up something called Responder that just captures SMB hashes across Windows network, and then try to use that hash, authenticate to different machines, and then see if you can get access to an admin and then become the domain admin and things like that. So yeah, it's feel like most of the time we would end up getting domain admin because networks for some reason are usually really badly configured.
Yeah, internal networks tend to be like, we're inside the network, surely it's safe. And they don't kind of, so that's where the whole zero trust thing comes in, where everyone should be authenticating to basically every device. So don't trust anyone externally, also don't trust anyone internally, make them prove that they are who they are.
Yeah.
As well as like the internals and the web app tests, or like a normal consultant will be often do externals, which is just like you get given an IP address, see what service are running on it. So common one is mail servers. See if you can send emails from the company like domain without anything. It happens more often than you would think. And it's obviously terrible because if you get an email, like a phishing email from like your manager's email address saying click this link, you're going to do it because you have to. Yeah, so things like that. Then there's also like physical, like properly physical security things where you walk up, you try and break in, bypass the doors. We've got like a guy who's like the best lockpicker in New Zealand. Oh, I say we, I'm not we anymore. But
like social engineering as well, so we try to break into the building.
Social engineering, the closest we would get to is that like tailgating people through the door, because it would probably be, I don't think there's anything which says that you're allowed to convince an employee to give them hand over your passwords. Although I know someone walked into a boardroom once and it had a password for something, I forgot what it was, but written on the whiteboard for the guests to use. I think it was the guest Wi-Fi or something. Yeah. But there's very amusing stories as an intern wandering around there. The pizza's arrived, so we'll let them set that up. But I don't know if anyone's looking for internships, but Aura takes people through Summer of Tech at the end of the year. I think it's usually about 3 interns, and as far as I know, there's probably going to be 3 spots open. My first year, I went to Aura. My second year, I went to Aura. I'm now in my 3rd year. So so you can go, they'll take anyone. Pardon? Yeah, so between November to, it's just summer internship. They would be very keen to take penultimate year and also final year students because they're always hiring. Yes, because I mean, they do grad roles.
Yeah.
So like juniors.
Probably not like not like hiring specifically for grad roles, but essentially full-time role. And there is a grad position called junior consultant, something like that, which you would be just out of university. And that kind of, that's not through Summer of Tech, that's just kind of constantly open. I didn't add any links to Aura, but basically you can just go on their website and careers, and there's a link, there's an email address, I think, just like careers@aurainfosec.com, and you can send through things, and they will review it as it comes in, and if they feel like there's someone suitable, basically.
Do you do like other areas of security, like applications like hardware?
Oh, yeah, good question. I think we do, not as common, because it really depends on what customer asks us to do, and and sales. If you ask us to do a job, salespeople generally won't say no, so they'll try to make a way for it to work. But so we had a guy that was like he did some research on like access card systems. So he there's a New Zealand company called Gallagher that has a lot of those access card control system things going on, and he was trying to break into those and see
when we
how
say
they're-
trying to, he like got into like, or found that 90 of them out of the 95 were vulnerable to some bug he found,
Yeah,
and then could break into
yeah.
like all of those. So
Yeah.
he was quite successful.
Yeah, he did a talk at Black Hat one year.
No, it was just KiwiCon. I'm pretty sure it's KiwiCon. Maybe.
I feel like he did a talk
Okay.
at Black Hat.
There's a talk
Anyway.
by a guy called Matt Daly on the internet.
Yeah.
And
Really specific.
yeah, you can
But,
ask us
yeah.
after on the Discord if you actually want to link to that. But it's pretty good, and he's down to earth.
Yeah.
Like you can understand what he says rather than just like some nerd speak.
All right, and just one last question out at the back. How many hours a
So,
week?
It's
just
a full-time. It's a full-time role. I know Aura is flexible. I know an intern who got, I think it was like 30 hours a week. One of the years I was there, because she had another job she didn't want to give up. But because that was throughout the full year. Anyway, they're pretty flexible, but it's full-time. Half-time wouldn't cut it, I don't think.
All right.
Awesome. Pizza's outside.
Cool. Thanks, everyone. We'll still be around. So. No problem. Should I stop screen sharing?
Yeah.
Oh, yeah.
So now enjoy the pizza.
I will leave it to you to do this.
Yes.
Oh, she's the girl that was. And you said she applied to